Hey guys, let's do a quick recap of Newton's second law. We also know that as F equals ma, where F stands for force, m stands for mass, and a stands for acceleration. If you recall, we have briefly talked about using this triangle to help us understand the correct formula for what we're solving for. For example, if I'm solving for force, because force is on top, I know that this would be mass times acceleration. So force would be mass times acceleration. If I want to come right here and I want to solve for acceleration, the F is over the M. So acceleration would become force divided by mass. And likewise, if I'm going to solve for my mass, if I were to kind of cover that up in my head, I would have F over A, telling me that would be force divided by acceleration. You want to make sure that you recall the correct units of measurements that are used. When we talk about force, that's going to be our newtons. When we talk about acceleration, that's going to be measured in meters per second squared. And when we talk about mass, that's going to be measured in grams or kilograms. So that would be critical to remember. Also, you need to make sure that you recall the acceleration of gravity will be 9.8 meters per second squared. So if you're given the mass of an object, you can almost always solve for the force of gravity by using the acceleration of 9.8 meters per second squared. Let's look at this and do a few examples together just to help refresh our memories. Okay, so we want to calculate the missing variable and draw a free body diagram when applicable. Our first example says we have a 10 kilogram object that accelerates up with a 5 newtons of net force. Now we also want to remember that a net force, if it's above 0, that gives us an acceleration, and that means that it's in motion or accelerating. So the first thing that I want to do is I'm going to come and draw my little free body diagram. Remember, the box represents my object, and I know that is 10 kilograms. I also know that my force that's going upward right here is going to have a net force of 5 newtons. I'm just going to write this so I can remember that. Now, I want to go ahead and solve for the information because I need to get a value for that. So if I come, I have F equals ma right here. I know that my net force is 5 newtons. And I know that my mass is 10 kilograms, which means I can solve for my acceleration. You can put A or X. Now, I can go ahead and work that out and isolate my variable. Like you've learned in math, where you can come and divide both sides by the 10 kilograms. Just like this, and this cancels out. And we get 5/10, which narrows down to 1/2. Is equal to our acceleration, and we have to make sure we put our units on there. So it'll be 0.5 meters per second squared. That's one way that you can solve for the acceleration, or you could think back to our triangle. And this is how I would do it. It just make life much easier. I know I'm solving for acceleration, so if I kind of block that out, I'm going to acceleration equals F divided by M, which comes, that gives me my force is 5 newtons divided by my 10 kilograms. And that's going to give me an acceleration of 0.5 meters per second squared. And that's my acceleration. Now, I'm going to think to myself, am I done? Is that all that I can possibly do given this information? Well, can we solve for the downward force for the force of gravity? We can, because we know the acceleration of gravity is 9.8 meters per second squared. So I'm going to come right over here, and I'm going to put F of grav, so I know I'm solving for the gravity. And my mass is 10 kilograms, and my acceleration is 9.8 meters per second squared. So when I solve 10 times 9.8, I'm going to get 98 newtons as my force of gravity. So that means I can come right here, and on my free body diagram, I'm going to put 98 newtons. Now, is my upward force going to be the same as the force of gravity? It is not, because I see that I'm accelerating up with 5 newtons of net force. So to calculate that net force, it has to be 5 newtons greater than the downward force, or 5 newtons greater than the force of gravity. So my upward force up here is going to have to be this 98 newtons plus 5 newtons gives me 103 newtons. That is my upward force, and that shows me that it is 5 newtons more than the force of gravity, which I was able to solve for because I know the acceleration of gravity. I'll also know that it is accelerating upward at 0.5 meter per second. Okay, let's look at our second one. Oh man. We need to calculate the force of a 6 kilogram box sitting on the floor. I know I'm looking for force, so I'm just going to put F equals MA. I know that kilograms represents mass, so I'm going to come and put in 6 kilograms. Oh, but I'm not real sure what my acceleration is going to be. Let me draw a free body diagram to try to help myself out. If I come right here, here are 6 kilograms. What forces are acting upon this box? We know that there's going to be the force of gravity. And because it's just sitting on the floor and we're not showing there's any motion, we know this norm force up here is also have to be present. We also know that those arrows need to be the same length because the force is the same. Can I solve for this force? I can, because I know that the acceleration of gravity is going to be what? 9.8 meters per second squared, right? So if I get my little handy dandy calculator, let me grab one real quick. Don't know this off the top of my head. And I say 6 times 9.8, that's going to give me 58.8 newtons of force. That means my force of gravity is 58.8 newtons, and also my norm force is going to be 58.8 newtons. Now that 9.8 that we used right here, remember this is the acceleration of gravity. That's why we were able to use that. And we know that from previous content. Acceleration of gravity is this 9.8 meters per second squared. That way you don't forget that. We doing okay so far? Good, good. Okay, let's look at the last example. We have 20 newtons of force applied to a 5 kilogram book. So I'm just going to come right here, F equals MA. I know that I have 20 newtons here. I know my mass is 5 kilograms. And then I do not know my acceleration. I'm going to think back to my little triangle right here, where I have F equals MA, and I'm solving once again for the acceleration. So I'm just going to kind of mark that out, and I'm going to get my formula. So to solve for A, it's A equals F divided by M. My force is 20 newtons, and my mass is 5 kilograms. Sorry, guys, got a little carried away there. And I know 20 divided by 5 gives me an acceleration of 4 meters per second squared.